Imagine that I just left my desk and I went to get a delicious latte from somewhere, and while I'm gone, trouble strikes. Our version of trouble today involves using some load testing tools that Microsoft gives you free with wide world importers. It's called the workload drivers. You get it from the exact same place you download the sample database on GitHub. I'm going to open that up, and I've just got it installed on my test instance's S drive. I'm going to open up multi-threaded order insert.exe, and I'm just going to use the defaults for this. It automatically is going to look for a local SQL server, and that's my little test instance, and look at the wide world importers database. It will be barraging wide world importers with inserts across 10 threads. So just using the default. So let's start that up. And so while things get busy on, that's mimicking our, order insert, mimicking a lot of customer activity. Let's say that Frank at our office also starts doing some work. And Frank, his work is simulated by a SQL Server agent job that our setup script created when I ran it. So Frank starts doing some work too. And Frank is running and the inserts are running. Let's pretend, that we can see the instance when I'm out at coffee. But if I was back in production, here's what I would see if I was looking at the instance. I'm going to just say, if I was there, I love SP Who's Active for active troubleshooting. I'm going to run this a few times and notice that things are changing. At the instant I ran this now, we do have blocking. Session 69 is blocking those 10 import threads. But if I keep refreshing this, it's rotational blocking. A lot of blocking in the real world is like this too. And that's why I call it the sneaky blocker. It comes and goes. And somebody will be like, oh, performance is terrible. And then you look at it, even if it's just 30 seconds later, sometimes it's gone. So you're like, it's gone now. So refreshing this, it's back. Frank is very persistent, but it will come and go because Frank isn't just holding a lock for a single long amount of time. He's causing blocking, and then one thing he does finishes up. This blocking is rotational. So, all right, let's say that everything kind of finishes up. Our inserts stop. The customer activity sort of wanes down. There was a big burst, but now it's less. And Frank finishes up too before we get back. And we're going to simulate that by stopping the job that, Frank is a robot in our case. So Frank's done with his work now. And let's say, we were getting our coffee and got an alert on our phone that there was blocking because there was one or more sessions blocked in the SQL server. But when we get back, hey, right now, things look pretty peaceful. When I run SP Who is Active right now, everything's finishing so fast I can't even see it. Did the blocked process report catch the sneaky blocker while it was in action? I am going to look at the results from the blocked process report using Michael J. Swart's free blocked process viewer. And this is what I mean by it making things nice to read as a big picture. I get a view of the blocking tree. The lead blocker was session 69. It was blocking session 63. And then behind session 63 were a lot of others as well. I can look back through history and see, was it always like that? At different times, right, I had slightly different blocking trees. And in the real world, this can be really useful to go through and say, okay, I've got lock weights. Is the lead blocker always the same query or not? Sometimes it is. Sometimes you've got multiple things that are causing blocking problems, and you want to know who blocks the most, which is the one I should focus on first. This bigger picture can help sort that out. It is totally normal that the XML is null for the lead blocker. That looks a little weird at first. To find out about this lead blocker, we want to look at the process it is blocking, or it could be blocking more than one. In this case, it's just one. If I look at the blocked process report, and that is the name of the report is about the ones who are blocked, they also will contain info about who's blocking them, you'll see. So we want to look at the XML on the one who's blocked to learn about the blocker. So I'll click on this. This will open up the blocked process report that the trace captured. I can see a couple different pieces of the XML here. I've got a whole section here for the blocked process that describes what it was. All I get for this one is some information to decode. It was a stored procedure in database ID 6. The stored procedure has an object ID that I'm given. I also get some information about the blocking process. This one, it was able to tell me a little more about. The one who was causing the trouble was Frank's update. I even get the information about a parameter that it was run at. The information that I'm getting here is not always complete. It's the input buffer. The same thing you would get if you ran dvcc input buffer from the command line, and it's just kind of like, this is the last thing I saw it push into the SQL server. If it's a really long query or something like that, you may only get part of it. You know, you do get things like the SQL handle and things where you could try to research, okay, what's the full text if it's still in memory? But, you know, I'm happy for what I get for free and the built-in stuff in here. So that's a bunch of useful info, though in a big one of these, it can be a little bit of a bear to read. And we do have information that we can decode in here. If we want to know more about this blocking process, more about Frank, let's go back in here. If I look over to the right, and Frank's blocking process is here, and I scroll over to the right, notice that it tells me that Frank is a SQL job, but the SQL job name looks really funny, right? Job, garbage, step 1. I don't have any jobs with this name. If we go into my SQL Server agent, this job is actually named Frank Did It. We have to decode a bunch of stuff in the blocked process report. So let's copy that job name there. I've got to scroll back. Got a little lost there. All right, so let's copy that job name. If you see that ever, you can decode that in the sysjobs table. It's the job ID. So if I select star from sysjobs with that job ID, I can see that is, the job named SW_Frank did it. So even things like SQL jobs, you're going to have to decode. I can script out Frank's update code. I was lucky this time, right? It did go ahead and just tell me, hey, the code that was running was Frank's update. So I'm going to do a quick SP help text and glance at Frank's update. Now, Frank's code is terrible. I say this and I know it really well because I wrote Frank's code and I worked pretty hard on this code to make it terrible. It's got a big transaction, an outer transaction. And then in it, it declares a cursor in there and it opens its cursor, and then it has nested cursors. It's declaring another cursor, and then deep inside its nested cursors, it's doing an update in there, and then, going out and finishing up all those cursors. This code's having some problems. So we can see we've got that big old transaction in there. If we want to decode the blocked process, right? All I got from that was an object ID and a database ID and the information that it's a procedure. I can go into that database And sys.databases will tell me who's database ID 6. It's the wide world importers database. And I can see that the blocked process was the procedure website.insert customer orders. That's what our load test was running. I've had to do some legwork, but I have at least figured out who Frank was blocking and who was part of that blocking chain. What were they blocked on, though? So I know that that was the procedure. If we want to decode even more, we really can. We get inside the blocked process report information about what the wait resource was. There we go. Highlighting is tricky. The wait resource in this case was on a page. The blocked process was trying to get a page level lock. The engine had selected a page level lock. And we get just this code for it, 6336868. Now, I don't know about you, but I do not memorize all my page numbers for all my databases. So let's go through and decode that. The wait resource can have different patterns. And I've got links to documentation for if you have the other patterns, how to decode them. Sometimes you get a key lock wait. We have a page lock wait. So we're going to do the page one today. All right, so here is my page resource. This is database ID 6. That's wide world importers. We could look that up in sys.databases. It is data file number 3. We have multiple data files for our database. And then this is the page number, the physical location within that file for that database where the page is that it was waiting for a lock on. We can use an undocumented command called dbccpage to see more information about what is on this page and what table does it belong to. If that stored procedure was really, really complicated, this might be one quick way to see that. Now, word of warning, dbccpage is technically an undocumented command in SQL Server. It is very widely used. Like, I am far from the first person to show you this, but if a problem happens when you're using dbccpage, Microsoft's going to say we just don't support that. You can run dbccpage against a restored backup of the database, though. You don't have to run it against a production server. So if you don't want to run undocumented commands against production, I support you in that, and you do not have to. But if you wish to run this command, the first thing to do is turn on trace flag 3604. That says for my session, when I run dbccpage, please show me the output in my window. If I don't run this, it'll just put the results of dbccpage in the SQL Server error log, which is not very easy to get. I have to keep refreshing and opening a file. So this makes my life easy. Now, I can plug that page number into dbccpage. I would like you, SQL Server, to give me information about the page in database ID 6, data file number 3, the page number that I found, and I'm going to use what's called dump style 2. dbccpage can return information in a bunch of different formats, and dump style 2 gives me the format you see on the screen that is a pretty detailed view, and there's a lot of info about this. If I scroll down and look in the page header section, I can see information that'll help me identify what table this belongs to, like what is the object ID for this guy. So let's see if I can, here we go. So metadata, I'm like, I know you're in here somewhere. Metadata, object ID, it's this value right here. And I can also see that for that object, it is index ID 1. If you see index ID 1, that is always the clustered index of the table. So we had blocking on the clustered index of the table with this object ID. And then we can use sys.objects to decode, okay, our blocking was on the table sales.order lines. All right, so we have set up the blocked process report to capture this information about the sneaky blocker that was happening. Your challenge for this problem, for this pattern, is simply to put into your own words a quick, short recap just of what's going on in the situation and what are some high-level suggestions that you can think of to stop this sneaky blocker from coming back. You do not have to go through and rewrite Frank's terrible code. Please, trust me. I know it's terrible, but if this was a real-world situation and you were working with Frank, your challenge is to come up with a way to describe to Frank and others, hey, here's just big picture what's going on, and here's some approaches I think we can take to get the sneaky blocker so that it is not causing so many problems.